Okay, so this problem here, we're given this. Now this is a big bird feeder. This bird feeder thing, it's big, man. Look at they tell us 150 Newton. What is 150 Newton here? If they get, is that the mass of the bird feeder? What is Newton a measure of? Force. Newton does the same thing as pounds. You know, if you talk about how many pounds you weigh, you know, I weigh 200 pounds, that's the force I exert on whatever's below me. So this is the weight of the bird feeder. If you know the weight of the bird feeder, how could you figure out the mass? How could you get the mass from the weight? Well, what's the equation for the weight of an object? mg. So if you want the mass of the bird feeder, the mass of the bird feeder would be weight over gravity. Bless you. So this is 150. Now remember, what's a Newton? A Newton is actually a larger unit. It's a kilogram meter per second squared. Okay? And then what's gravity? Meter per second squared. So I round gravity to 10 in class. In the homework, do 9.8, because then your answers will match up with the answers in the back of the book. So gravity in class is 10 meter per second squared. So then that cancels, and we get 15 kilograms. My. 15 kilograms is a lot. You know, 1 kilogram, this thing right here, this is 1 kilogram. So feel that. Imagine that times 15. Is that a big bird feeder? That's a big bird feeder, okay? But whatever. Okay, so I just wanted to mention that. So what this question wants us to do is solve for the tension in each rope. So there's 3 ropes here. If you look at this point right there, there's 3 ropes that connect to that point. So I'm going to let's call this, what do we call force in a rope? Tension. So if we're focusing on this point right here, which way is the tension in this rope? It points up to the right. Now what if you're focusing on this point up here? Which way would the tension be pulling? Back like that. This is, Newton's third law. Every force has an equal and opposite force. Okay? So let's call this T1. All right, we'll call this T2. And then pulling down will be T3. Now if we're focusing on the bird feeder, which way is tension 3? If you're focusing down here, which way would tension 3 be? Pointing up. That third rope is holding the bird feeder up. But if you're focusing on this point up here, that tension is pulling down. Does that make sense? Okay, so we got T1, T2, and T3. So let's start by finding T3, which, can anybody tell me right now what T3 has to be? It's got to be 150 newtons, and I'll show you like the super physics way to show that. If you do a free body diagram for the bird feeder, so here's the bird feeder right here. So we have mg down, and mg is equal to 150 newtons. And then what's holding the bird feeder up? Tension. What are we calling this rope right here? 1, 2, or 3? 3. So this is T3. Tension 3 is holding the bird feeder up, right? Now, is the bird feeder accelerating? Or is it just sitting there? It's just sitting there. So if the bird feeder is not accelerating, what has to be true about these 2 forces? They have to be canceling. They're the same. They're equal. Oh, and also, look there's no normal force here. Why do we not have a normal force? Because it's hanging. It's not resting on a surface. So when you sum these forces for the bird feeder, in the y direction, we have T3 up and then 150 down. What is the sum of the forces always equal to? ma. Well, that's a y acceleration. So what's the acceleration of the object, of the bird feeder? 0. So what must T3 be equal to? 150. So we found one of the tensions. We found T3 equal to 150. Okay, now, how do we get T1 and T2? Well, what point are we going to focus on? If we're trying to find T1 and T2, which point do we need to focus on? So here we have T1, here we have T2. We're going to focus on what point? Right here. Why does that make sense? Why are we going to focus there? Because that's the point where all three ropes come together, right? So let's do a free body diagram for that point. So there's that point. So here's your free body diagram. How many forces are acting at that point? 3, the 3 tensions. So we have T1 going up like this. Here, let me make that bigger. Do a nice big one. So we got T1 pulling up like that, where this angle in here, always show your angle, off the horizontal. So that's 30 degrees. And then we have T2 pulling like that, where this angle in here is 60 degrees. And then we have T3, which we just found, pulling straight down. All right, so that's the free body diagram. That's going to help us. That's the first thing you do. Now, are T1 and T2 perfectly X, perfectly Y, or both? They're both. So just like we did last chapter with two-dimensional motion, what you have to do whenever you have a vector that's not perfectly X and not perfectly Y, you have to break it into components. So for T1, I'm going to show X component, Y component. For T2, X component, Y component. So just so you understand the big picture here, is this bird feeder accelerating? Nope. So what must be happening to the forces in the X direction and the Y direction? If there's no acceleration, because look, this chapter is all about Newton's second law. What does Newton's second law tell us? Net force equals what? Ma, mass times acceleration. And another way of saying that, bless you, the sum of the forces equals ma. Those are identical, right? So look, if there's no acceleration, then what will that mean about the sum of the forces? They'll be 0, or the net force will be 0. So what does that mean for this problem? Well, look, how many X forces are there in this problem? 2. We have this X force right here pointing to the right, and we have this X force pointing to the left. What must those forces be doing? Canceling, right? Because if they weren't canceling, then there'd be an acceleration. Okay, now let's look in the Y direction. What is happening in the Y direction here? How many forces do we have in the vertical, in the Y? We have 3. We have 2 that are pointing up. That points up, and that points up. And then we have 1 pointing down. So what must those 3 forces be doing? Canceling. So what we're going to do is we're going to turn this idea into an equation, into 2 equations. So it looks like this. We're going to sum forces in the X direction, and we're going to sum forces in the Y direction. Okay? And here you got to do trig. So for example, what's this X component right here going to be? It's the same thing we did last chapter with velocity. Remember breaking velocity apart using trig? All this is a right triangle. It's a right triangle. That's all it is. So what will this X component here be? It's going to be cosine 30 times what? T1. Should I show? How many of you want me? Should I show how I got that? You guys get that? It's just use the definition of cosine. Okay, what's this guy over here going to be? This guy over here is going to be cosine 60 T2. Negative. You gotta put the negative in yourself. Where does the negative come from? Well, what's our sign convention? Our sign convention is plus, minus, like that. Okay, so summing the forces in the x, we get cosine 30 t1. Who's that? It's this guy. Minus cosine 60 t2. That's this guy. All right, any other forces in the x direction? Nope. So by the way, what did we just do right here? What did we just do? We summed the forces. We added the forces up. What is the sum of the forces always equal to? Not 0. Sometimes it's 0, but what is the sum of the forces always equal to? ma, where that's x. Now, is the bird feeder accelerating? Do we have an acceleration in the x? No. So what can we do? We can cross this a to what? 0. So we just put in a 0 there. But technically, just be aware, technically it's equal to ma. It's always equal to ma. All right, let's go to the y direction. So looking at the free body diagram, we have 3 y forces. So let's start with this guy. So what's this guy going to be right here? That guy is going to be sine 30 t1. Now let's go to this guy. What's this guy going to be? Plus sine 60 t2. And then this guy. Minus, why am I making him minus? Because which way does he point? Down. Okay, minus 150. So what did we just do right here, guys? We summed the forces. What does Newton tell us about the sum of the forces? The sum of the forces always equals ma, where that's a y acceleration. Is the bird feeder accelerating in the y? Nope. So what can we do to that y acceleration? We can set it to 0. We go, okay, cross that out, just replace it with 0, because there is no acceleration. Now, the hard part is done. We've summed the forces. Now what's the rest of the problem? The rest of the problem is algebra, which I'm not going to show on this. You guys can do algebra. I'll give you one hint though. Look, convert these, cosine 30 and cosine 60. Change these to decimals. It's better. Cosine 30 is 0.866. Cosine 60 is 0.5. Sine 30 is 0.5. This will make it a little easier, right? That's what I do. Change it to decimals. And then basically, you guys know, remember from math class? In math class, all this is remember in math, 2x plus 3y equals 7. 5x minus 4y equals 2. Can you substitute those together and solve for x and solve for y? Yeah, dude. That's all this is. Because we have 2 equations, right? We got 2 equations and how many unknowns? 2. What are the unknowns? T1 and T2. If you do the algebra correctly, T1 comes out as 75 and T2 comes out around 130. I think I rounded that. And then of course we already know T3. T3 is 150. Okay? So the rest is algebra. I'm going to leave that up to you. But that's how you set the problem up. Ba-bam! That makes sense? All you're doing is summing the forces. Okay.